Let's get started. So it seems like most people are in Europe, around Amsterdam area. But welcome everyone. Thank you all for joining us today. My name is Lynn and I'm part of the talent branding team here at Miro, and I'm very excited to welcome you to our first virtual engineering meetup, where some of Miro's front-end experts, Alexandra, Ahmed, and Gonzalo, will discuss the topic managing hypergrowth with distributed front-end teams. Before handing it over to our first speaker, I'll quickly walk you through some best practices for the Q&A. We'll have two Q&A parts, one after the first two presentations, and then the other one towards the end. Please add any questions you might have along the way in the Q&A tab, which you can find in the bottom bar in your Zoom window. This will help us to keep track of the questions that come in, but of course, you can use the chat for any other comments or anything else. Questions are encouraged, and you will also be able to upvote any questions that come in. To make it even more fun, there will be prizes for the people submitting the two most upvoted questions, which will be announced at the end of the meetup. But for now, I'll hand it over to Alexandra, who will talk to us about design reviews for multi-team companies in hypergrowth. And I'll stop sharing my screen.
Thank you, Lynn. I will start sharing. Can you see my screen? Perfect. All right, so hi everyone, I'm Alexandra, and I work at Miro as a front-end engineer on the enterprise security team. Today, I'll share some insights into our technical design review process. So first, let's start with some context on what hypergrowth looks like from an engineering perspective at Miro. So as engineers, we need to juggle monolith applications, although on the front end, we are working towards a Monorepo right now, but we still have to work with one big code base, basically, respectively on the back end and front end. So different teams end up working on the same code very often. We also have to deal with code ownership overlaps. So we manage our code ownership with code owners' documents, but of course, the code isn't perfectly sliced between teams. And also because of the way our verticals work, we can have, for instance, like an enterprise team owning a part of or making changes to, say, the board sharing model, while the overall model is owned by the activation team. At the same time, we do a lot of ownership transfers to new teams because many new teams are created to take over responsibilities of existing teams for more in-depth focus. And in such cases, we share ownership at least for a while to ensure a good transition. So in practice, all this means that we need to maintain a cross-team and very collaborative decision-making process. So one of the ways that we try to do this is also by writing design review documents. So what is a DR for most of us at Miro? And most of us is important here because we share guidelines, but we are a big company. So sometimes different teams do different things. But of course, a DR is a document where we propose a technical solution. And the footnote here is that we do it mostly for cross-team complex engineering problems, because it would be expensive to write DRs for all the changes we make. At the same time, this idea of what deserves a DR and what doesn't is already a bit subjective. And as we will see later on, sometimes different teams have a different take on it. Coming back to what a DR is, it's also a document to facilitate iteration and reveal possible issues at an early stage, ideally before implementation starts. And iteration is, of course, an essential part of the software development cycle. We do it in PRs, for instance. But what we've learned at Miro is that sometimes it's really useful to take a step back even before you start coding. DRs are also meant to involve component owners, so code owners of components we want to add changes to, both in the sense that they can become a co-designer of the solution and in terms of transparency, so that they are informed of the changes. And last but not least, DRs are important for documenting agreements and decisions, especially as we grow as a company. This becomes a real necessity for us. So how does a DR look like? Most probably at Miro. And this is the quote unquote official template we use. So it includes an issue because it's important both for DR creators and component owners or reviewers to understand the problem we're trying to solve. It also has a solution summary, of course. And here we differ a little bit from other DR practices where sometimes more solutions are being proposed and eliminated one by one according to goals, because usually we only propose one solution, the best one we were able to come up with after investigation. Then we also have the actual component changes, and here we often find code snippets or diagrams with explanations. Sometimes, and this is optional, we also have related requirements like monitoring or alerting, or a testing plan if we need intricate testing. Next, we have a Jira Epic link, which is important to show how the work is planned or structured, or if there's an estimation. Then we have a release plan, because often at Miro, we work with feature flags or beta releases. And lastly, we have a list of component owners, and ideally, the goal of the DR, of course, is to get approvals from all these owners. So in practice, this process of getting all the approvals looks a bit like this. We create a first version that we share with component owners, and we wait for their validation. And two things can happen here. First, we have the happy path where no significant concerns are raised and the DR is approved. And the word significant is important here because we try not to focus on too many implementation details at this stage. They can also be addressed later in PRs. And then we have the other path where significant concerns are raised, here also with two different scenarios. So first, when the reviewers agree with the overall solution, but with their expertise, they're able to suggest major improvements. And here the process is relatively simple. We just iterate with their feedback until the DR is approved. And the second case is when the reviewers don't agree with the overall solution. And what usually happens here is that the DR creators need to make a case for their solution. Usually it's good practice to also schedule a meeting so that everyone can discuss things over and get on the same page. And once the solution is accepted, we continue with the iteration until the DR is approved. What if the solution isn't accepted? Well, thankfully, I don't have such examples from my own team's experience. And I think in general, we try at Miro to negotiate rather than escalate things. But the guidelines in this case say that component owners or reviewers should have the last say. So with all this in mind, what is our experience with DRs at Miro? And here I can speak mostly from my own team's experience. And as with everything in life and in software development, we've got successes and failures. And I'll start with the failures because I don't want to end on a sad note. The first failure is not related to DRs really, but with the lack of DRs when they are skipped. And this goes back to this idea that I mentioned before, that sometimes it's subjective to decide on whether something deserves a DR or doesn't. So what happens if the DR is skipped and then later on we realized it shouldn't have been? Usually we end up with either cryptic or really huge PRs, which sometimes evolve directly from proof of concept branches and which are hard to understand from a reviewer's perspective. PR descriptions can help here, but at that point, what you see as a reviewer is only the code outcome of a complex thought process that went into the solution. And it can be hard to trace back the original problem, the overall solution, and to actually make a significant contribution by suggesting improvements or spotting issues. At the same time, it can also be a little late, especially with the huge PRs, because a lot of work already went into this particular solution. Other issues we've seen when we do write DRs, we've got delays and idleness costs sometimes. DR reviewers can be busy, and we currently don't have an SLA for this. At the same time, while waiting for approval, DR creators, for them, it's a little hard to start on another big initiative. What we try to do in our team, for instance, is to plan the DRs in one sprint together with other issues, ideally smaller ones, and then the DR implementation for future sprints. Other costs we've encountered are related to iterations overhead when the reviewers have a lot of suggestions or they don't review all the changes at the same time. The process can become overwhelming for the DR creators. We sometimes also have incomplete DRs, either because the investigation is incomplete or some changes were dismissed as sort of implementation details. And lastly, we have the somehow opposite problem when there are too many implementation details or it focuses too much on code samples rather than the overall solution. And then the DR starts to look more like a PR. So these are the most common cases of failures, but on the bright side, we also have stories of iterating on solutions and improving them considerably with the component owner's perspective and expertise, catching side effects of proposed changes at an early stage, catching security vulnerabilities, because often we add not only component owners, but also expertise teams like the security teams to review. We've also experienced that although the DR process can introduce delays, it can also save time later on in the implementation and review stages. And we've also had a positive experience with documenting agreements and decisions. So in conclusion, and this might be more of a common sense conclusion than a revelation in any way, but what we've learned is that DRs come at a cost and they're no silver bullet for our hypergrowth related complexity. But they've challenged us to come up with improved, more collaborative and better documented technical solutions. So at least from my own team's perspective, they are definitely worth the while. That's it from me, and I'll switch it over to Ahmed for another type of hypergrowth challenge. Thank you.
Thanks, Alexandra. I will share my screen now. So, hi everyone. My name is Ahmed. I'm a staff software engineer at Miro. I'm currently working on the platform team. My main focus areas is actually web SDK, developer experience, and also I'm involved in the front-end infra initiative of the company. So today I'm going to talk about Monorepo tooling and some of the challenges that we face in the front-end infrastructure team because of our hypergrowth that we are currently in. So first, what's front-end infra? In Miro, the front-end infra team is responsible for all tooling and infrastructure that's front-end related. For example, publishing, creating packages, CI/CD, private registry, local environment setup, package management, and build, or also tooling setup like ESLint, TypeScript configs, Jest setup, etc. Why do we need such a team? We have, as Alexandra mentioned, we have two big monorepos, one on the server and one on the client. Both have multiple hundreds of thousands of lines of code, and also our engineering organization grew 3x from 2020 till today. So that's around 200% increase. All our repo tooling and infrastructure was not prepared for such growth in a very short amount of time because no one really plans a pandemic. So you cannot anticipate this. And product teams need to focus on delivery and features. So with this growth comes some of these problems that we faced, and we decided to kind of tackle them with the front-end infrastructure. First thing, that we didn't have any metrics or any data about our builds or tooling pipelines. So no one know actually on CI and CD what's the bottlenecks or anything that actually blocking us from moving fast. CI and CD was around 30 minutes. Sometimes I saw like 45 minutes also, which is really a lot, especially if you multiply this by the number of engineers that you have. And then we have also problems. You need to wait on your PR until it passes all the tests. So you wait for 30 minutes, someone else merged before you, then you have to wait again for another 30 minutes or 45 minutes. So you can basically waste your whole day waiting to merge your PR. So that was really not a good way to work. And it was blocking lots of things to move fast. Local commands also were getting slower. Things like ESLint dot or TSC dot don't scale very well when you have more engineers and you have lots of lines of code. These can work in very smaller kind of like code bases, but when you have hundreds of lines of code, it's really, really expensive. Right now, one of our bottlenecks is actually TypeScript, and also doing type linting, which is ESLint using TypeScript to do linting. So that's something I was working on in the last couple of weeks. And without the TypeScript, the ESLint can run on our code base pretty fast, actually, like maybe maximum 1 minute. With TypeScript, I was getting out of memory errors, so it would totally crash. So that's really something that we are looking into right now. We also used to have a private registry using Nexus. This was sometimes randomly goes offline, which breaks the builds, breaks CI and CD, even breaks local development because we depend on this, and blocked developers basically from doing any of their work. And if you see this point with point number 2, this adds to the problem. So sometimes CI is broken, so you don't even need to wait for the 30 minutes. You have to wait until Nexus comes online, and then you have to do the whole kind of thing again, wait for 30 minutes or 45 minutes, right? So it was not really working. There are lots of time wasted there. We didn't also have any Monorepo tooling in place to manage our local packages or anything like that. So in order for you to do yarn or npm install or something, you had to cd inside this folder and run your commands and go outside of it. And we didn't have any way to query the whole code base to understand how many packages do we have, what are the dependencies there, etc. Everything was really, really manual, and you had to do it in each folder by itself. And lastly, there was no clear ownership on who owns this part of the code base. It was mostly individual efforts most of the time to try and fix it or do quick solutions just to fix the current problems right away. Sometimes also some teams took shortcuts in a way that's because as we mentioned, it's a massive monorepo, so some people own some folders. So if they don't agree, for example, with some ESLint tooling of the global ESLint tooling, they just threw in an ESLint RC file inside their folder, which complicated things even further and made tooling even slower. Because when ESLint, for example, traverses the whole tree, it sees another file set up inside the folder, then it needs to also redo calculations depending on this setup, right? Especially also if you have root equal true, which means that this ignore everything you did before and just start again from here. So to tackle all these problems, we created a virtual team. What is a virtual team in Miro? A virtual team means that this is not a full-time dedicated team. This is, right now we are around five engineers. Every one of us is dedicating around 15 to 20% of their time to work on this. In the future, we might actually have a full dedicated team to work on this full-time. So what did we actually do? From 2020 until now, we've made some progress. It's not perfect yet, but there are lots of things that we can say that we improved. Right now, there is metrics on CI. You can see on every step on CI and CD how much time it takes and which commands also, like by command. It's not only the whole total, but also per command. Build CI and CD times went down to around 10 minutes now from 45 minutes. We are also working on revising all our configs for ESLint, TypeScript, etc. As I mentioned, I was working on that last a couple of weeks, and my colleagues are also still working on some of these things. We are also looking at new tools like SWC, ESBuild, RSLint, etc. For those who don't know about these tools, these are kind of like next generation, let's say, front-end tooling. They are mostly built with Rust or Go. They are actually not built with JavaScript. And some of the big frameworks are starting actually to use them. So if you use, for example, Next.js, they already released their latest version, which already have SWC instead of Babel to transpile all the code and stuff. I think it's experimental. You need to enable it. But there is like a huge move towards these kind of tooling because it actually adds, it gives you lots of speed and it can handle bigger tool bases in a code bases in a better way. We also have a POC to use ESBuild. So one of my colleagues also are working on that, which actually will reduce our build time quite a lot. We also migrated from Nexus, which is the private registry that we have, to Artifactory. And this is now much, much more stable. We barely got actually any downtimes or any issues. And also it helps us keeping everything in one place, because we also push some artifacts from the Java backend to the registry. Initially, also, we moved from NPM 6 to Yarn 1 because we needed workspaces support. As I said, we have lots of local packages, and NPM at that time didn't really have that support. Even NPM 7 workspaces support is not as mature enough as like Yarn workspaces. But currently, we are looking even into PNPM or Bazel or Turborepo. These tools also that works with like monorepos. Some people might ask, why not Yarn 2 or Yarn 3? Because Yarn 2 and Yarn 3 were released with lots of backwards incompatible things. Basically, for example, lifecycle scripts in package.json. They don't support this in a backwards compatible way, like NPM or PNPM. There's also lots of differences when you run the scripts. The environment itself is a little bit different. And this will require us to do a lot of work to make it work. So that's why we're looking for something that actually still work the same as what we have, but gives us better improvements overall. I want to end this with a little bit of conclusion that's like tooling and infra is important in large scale teams. And also it helps and impacts your team day-to-day work. So that's why it requires special attention. But this is not a silver bullet. This is not also something that applies to all teams or every company. In our case, this applied maybe to us because we have seen these problems and we have grown so much that everything started to kind of not break down, but it shows that it didn't scale very well. But in general, this is a very important thing to look at in your company. And this is kind of like low-hanging fruit, I would say, in smaller teams, that you can really, really affect the productivity of every other teams who's working on your code base by just making sure that the setup and everything works correctly and things that can easily scale to a certain degree, because at some point you might need a dedicated team for that. So yeah, that was my talk. And now to Lynn.
Right. Thank you so much, Ahmed and Alexandra, for sharing. I just want to mention for anyone who just logged in, and we're doing this little friendly competition here today, and we're encouraging Q&A. So if you have any questions, you can also upvote other people's questions, and the two most upvoted questions of today, the people that submitted those, they will receive a small prize from us. So just to make everyone aware of that, I see that we have two questions that already came in. And the first one is from Ahmed. It seems you opted for dividing the developers into backend and front-end teams instead of feature X team or service X team. Was there a particular reason for this?
So it's not actually, we don't split the teams as front-end and back-end teams. We have, so Miro, inside Miro, we have streams. So for example, I'm in a platform stream, Alexandra and Gonzalo are enterprise streams. And inside these streams, there are even smaller teams. So in my case, there's a web SDK team, there's a developer experience team, Gonzalo and Alexandra, she said already, in the enterprise security team, Gonzalo also in one of the enterprise teams. So we have teams, feature teams, or like not feature, but specific teams to do lots of things. It's just that our code bases were split this way, were created this way for reasons that honestly the three of us don't know, because when we joined later, so we don't know why it was split like this in the beginning. But yeah, we have different teams per requirement. It's not split as front end and back end.
All right, thank you. All right, another question from Stuart. How do you keep track of and share who is in what team? Where would one go to see the team structure, and how do you maintain it?
I can take this one. It's very difficult sometimes. You have no idea who you're supposed to contact at times, but we try to keep track of it. For instance, in our code owners documents, when we tag teams to add them as owners of different files and folders, members of those teams are also specified in there. So you can find them in there. You can find them also in Confluence. We try to maintain, sometimes it's hard because a lot of people come in, but we try to maintain it updated, who is in which team in Confluence pages. And also in Slack, we have our little description where we everyone tries to mention what team they're in and a welcome letter and so on. So this is how we try to do it.
Cool, thank you. All right, just make sure I tick off the questions that have been answered. Another question from Aryan. 10 minutes for a CI/CD pipeline seems pretty fast, especially for such a UI-focused application. What do you do? No, what do you do test? Huh? What do you do to test your front end?
Yeah. Okay, that's for me. So yeah, we have unit tests. We have also end-to-end tests, and I think we have some integrations tests. So unit tests and some of the integration tests are owned. Unit tests are fully owned by the teams. Integration tests are kind of shared sometimes between teams and QA team. And currently, end-to-end test is owned by the QA team or the test automation team. This might change in the future, and the end-to-end test can actually come back to the teams. On 10 minutes, like the specific part of like 10 minutes pipeline, we have. Like initially, we didn't have lots of parallelization for some of the tasks that were happening. Now we have actually added lots of parallelization for these things. So tasks like linting run on a separate task. I think we split even the linter to have like 2 or something, and the tests are also running in 3 or 4 parallel tasks. Yeah, 3, as Gonzalo said. So we add lots of parallelization right now, and also we tweaked a lot our configs. So we also tweaked Webpack, Jest, and all of these tools to try and kind of squeeze as much as possible. And there's still time to actually squeeze more. So that's what we actually are doing right now.
Cool, thank you. All right. Yeah, we still, according to the schedule, we still have some more time for questions. So I'll just dig up some questions that I have here. For Alex, how long does it take to write a DR, and how long does it take to be approved?
All right, so of course, it depends on what you write a DR for. If it's, for instance, we're writing now a DR for 2-factor authentication. That's pretty huge. That will take a long time. But in principle, we do a lot of investigation beforehand, of course. And I would say kind of the average time in my team's experience would be about 2 or 3 days. For bigger initiatives, a little bit more, of course. Now, when it comes with approvals, it definitely takes a bit longer because, again, reviewers are busy and you need to ping them to check your changes from time to time. And I would say a week would be the average. Maybe less sometimes. It also depends on how often you work with the other teams. Maybe sometimes if you know them better, they'll do it a bit faster for you. But yeah, I would say about a week in general.
Cool, thank you. And how many teams are usually involved in each DR? And do you have some examples of DRs that you could share as well?
Sure. So I would say in general about 3 or 4 teams. It also depends on whether we want to add expertise teams like the security team, for instance, but that's the average. In terms of examples, like I said, we currently work on a DR for 2-factor authentication for our enterprise customers. In the past, we've recently worked on a DR for a technical initiative, which was to migrate from an older state management library called Cerebral to Redux in our application. And that was a massive technical initiative that needed a very well-structured plan. Other type of DRs, we also had React refactoring recently from AngularJS for certain components that we had to write DRs for. Also DRs related to changing permissions or certain features sometimes that affect the core of the application. I would say these are some examples.
Great. Thank you so much for sharing. I also have a couple of questions for Ahmed. What's something that you recently improved or struggle with right now?
Yeah. I think I mentioned that, which was I was working on the ESLint in just a small part of the application. Actually, it's not like everything. It's just like the packages folder that we have. And as I said, I struggled a lot to get it to work with TypeScript because of like out of memory issues. So that's something that I was doing lately. I managed to improve it, thankfully, and make it work. But also in general, the struggle with like these type of tooling is it is too deep into like the repo, right? And if it was not done in a proper way from the beginning, these things cascade. So you cannot just like, sometimes you try to, as much as possible, make the change in a specific folder or in a specific part of the app, but sometimes we can't. And we have to blow up the PR in order to do this, because once, for example, types, if you make type checking a little bit strict in one folder that was not strict before, then all the imports from this file will actually blow up. And it will say like, oh, errors, the types are different now. So it's a little bit hard to balance these changes together because the same applies to lint, for example. Once you just have like a strict lint in one package or something, you'll see massive amount of errors because before they were not checked. And because of the lack of monorepo tooling also in the beginning, resolving the dependencies is still an issue. So sometimes things get ESLint version that's different than the version that we have at the root, and we have to deal with that. Thankfully, this a little bit is improving more like a bit by bit, this part, but changing the configs is very, very hard. And it requires like lots of work, and sometimes, and also you don't want to block engineers. I mean, you don't want to say like to everyone, hey, we have this massive PR that changes like 10,000 files. Please merge it back into your branch and fix all the like the merge conflicts. So it's very hard to balance these things. So that's the major struggle here. Yeah.
All right. Yeah, we have time for one last question. How do you decide on a roadmap for the infra team?
That's a good one. So we started first by looking at things that we can do quick, fast, and small changes that can actually improve the life of other engineers quickly. Basically, low-hanging fruit, right? If we can find these things and start quickly, this will do multiple things. On a social level, it will create trust between you as a team and the engineers. Two, it will still improve their life in some aspects. And three, it will give us trust on actually moving forward. We do have lots of plans and things, but we take it from, so our team is a little bit different than product teams because our metrics or anything like that will not be really product focused, right? It's more kind of like, it's really hard to measure to some extent. Like some changes are hard to measure, but some things can easily be measured, like CI and CD improvements there. You can easily get that. But things like linters and types, you can get it through bug reports or how many times engineers complain about specific thing, right? And then you can prioritize with these type of things. It's a little bit hard than normal kind of like product team where you can easily prioritize things. So for us, basically low-hanging fruit first, things that kind of stabilize the structure of the repo and the configs and like things like linter, checker, etc. And then we can build on top. once you stabilize the base, you can easily build on top of that. But if you still have a shaky base, you will never actually be able to move like with trust. So I would say low-hanging fruit, then the base requirements, and then anything else that comes later.
Cool. All right. I see that we have one more question coming in from Aryan. In a hyper-growth company, new features can be very important. Company success might depend on it. How do you balance feature developments and working on tech debt? Any takers?
If you want, I can take it. That's a very interesting question, one we struggle sometimes a little bit. I would say the balance depends very much on multiple factors. There are quarters when we have tons and tons of features that we need to develop, and we're like, oh no, we cannot fit even one more thing into this quarter. There are quarters that are a bit slower because we're already rolling out what we did maybe in previous quarters, and it takes more coordination with sales teams or customer success teams, so we don't start piling up the features that we want to roll out. But in general, we have like a general level agreement with mainly product people. That is at 20% of our sprint time we can dedicate on technical initiatives. Sometimes it's a bit more, sometimes it's a bit less. But on the baseline, at least 20%, you can negotiate and put it inside the sprint.
Anything to add, anyone? Or okay, great. Thank you, Gonzalo. Well, I guess we can hand it over to you then.
Okay, thank you very much. So, hello, my name is Gonzalo, and today I will talk about accessibility with some ideas about robotics at some point. So let's get started. Accessibility is a hot topic nowadays. The world is becoming more and more connected. If your product or website is not compliant with accessibility standards, you need to slow down and have a hard and honest talk. You need to get together with your leaders and acknowledge you have a problem. Your website is not for everyone, and you might be assuming all of your users have the same abilities. Abilities can be cognitive, auditory, neurological, physical, speech, or visual. To put it into perspective, statistics show that 15% of the world's population has some sort of disability. By 2050, the number of people 65 and older is expected to double to 1.5 billion with a B. We are in hypergrowth at Miro. Our usage is growing exponentially, and that made us realize that we were lacking in some of these areas. Our segments could become even bigger if we allowed every human to interact with Miro. We were also growing a lot internally, so we had to address several accessibility issues before newly hired engineers started to grow our code base even more. I like to draw a parallelism between accessibility and software quality. Many of us like to have our testing automated to save time by reducing manual work and to speed up our release cycles. Test early and test often is a common good practice among quality practitioners. If you only spend time developing features and leave testing to the end, the complexity of your app increases and the investment is now huge. Imagine if one day you showed up to work and all of your tests were gone. How much time would you need to rewrite them all? Something similar happens with accessibility. Making an existing website or application accessible is much more complex than developing accessible features as you go. Test runners are just different inputs to your application. They click their way through your flows, ensuring everything works correctly. Having accessible features makes it easier to write such tests, as information is encoded using a more expressive language than just using maybe IDs or class names to select the things that need to be tested. What helped us during our implementation of an accessibility standard was starting with the small parts of our application and zooming out into more complex flows and components. As you can see in the first small screenshots, there are just a couple of elements at play there. As we zoom out and start building bigger components, the number of elements start to multiply. Each one of these elements have different hover state, focus state, disable state, and screen reader only behavior. This is another great case to start thinking about accessibility in early stages, and yeah, not in a big bang like we try to do it. It takes less cognitive load to make 2 or 3 elements accessible than to make 10 or 15 of them. I'm just showing one example of the models here, and we have hundreds of them. Many of these components, atomic components that you see here, can be part of a design system. And by making them accessible, all the front-end developers of your organization benefit from a performance boost. You don't need to reinvent the wheel on every flow and rethink accessibility. Yeah, and as well as it was mentioned before, I work in the enterprise security team together with Alexandra, and we focus mostly on settings for large companies with more than 10,000 users. Our team also owns some features that affect the board experience, which most of you might be familiar with. In fact, it is what you're seeing right now, as all of these presentations were done using Miro. And yeah, making the sharing dialogue or the board details or anything that is not part of the canvas itself is pretty straightforward. But the board and tools are not so easy to make accessible, mainly because lots of different types of content can be created and linked with each other, and because the board itself is an infinite canvas, which is hard to comprehend in accessibility terms. So yeah, we're still working in making this experience accessible, so we will have more updates about this in the future. And yeah, now I want to discuss very briefly some ideas about robots. And I will start by saying that socially assistive robots help humans through social interactions and performing different tasks. Why is this relevant in an accessibility talk? I have a strong belief that in the near future, automation and robotics in particular will be a pervasive aspect of our daily life. I would really like a helper robot like the one in the first picture on the top right to deal with things at home, or maybe to help me prepare dinner or things like that. But imagine if the second one, the one below, could be a user of your application. This robot is called Asimo, and it was developed by Honda. It is real, not just an image like in the first one. And it is currently showcasing different physical abilities. So surfing the web should not be so hard to implement compared to that. For sure, this takes the screen reader technology one level forward. But yeah, the applications we use nowadays in the internet have a huge social impact, and being left out is a problem. And when they become massively available, these robots could help us bridge the gap. As a bit of context, robots have been improving a lot in the last 30 years. They are now able to jump, walk up a flight of stairs, some even do parkour. At the same time, on the other side, we have Moore's law, which states that the number of transistors in microchips doubles every 2 years. With this exponential growth, robots can become an interface between our apps and our users in the near future, especially for those with different abilities. If a robot maybe can make you a coffee, why can't it book your next flight or help you buy in cryptocurrencies or help you run a design sprint using Miro? Making our app accessible makes them easier to parse for screen readers and eventually, I believe, robots. This is because information is encoded and connected to other things rather than just presented visually to the user. It can be consumed in multiple ways depending on the situation and the abilities of the end user. Once the web is accessible, the only thing we need is an interface for these robots to consume it and help other humans interact with it. And yeah, last but not least, I want to share some learnings we found during our own process in making mostly parts of settings accessible. And yeah, first of all, it was very important for us to work with experts of the field. We worked with external consultants that have a lot of experience helping other organizations achieve accessibility certifications. Online research is good, you can do it yourself, but many times it's not enough, and we learned it the hard way. At the beginning, we tried to do it by ourselves, and we kind of ticked off some parts of the accessibility initiative. But then when we discussed with the accessibility expert, they had more and more suggestions to be done. And that is mainly due to that the standards can have multiple interpretations if different people read them. We suggest you prepare an environment where these experts can use all of your features, iterate with them, and then discuss improvements and solutions. Another tip is to test directly with screen readers. As accessibility reports, they're good. They can hint you some of the fixes you should do, but they are sometimes not enough to make the solution usable for people with different abilities. You need to actually experience it to see if you can move forward. These reporting tools, what they do is they usually just scan the DOM, so they won't click their way through different flows and open different kinds of models. Another thing is that, yeah, sharing knowledge about accessibility throughout all of your teams was crucial for us, at least, as we all needed to have this in mind while developing new features. Company-wide trainings on accessibility best practices were also very helpful to spread this kind of knowledge. And beside the technical aspect of it, there were some design changes that we needed to do. So the knowledge sharing was not for engineering teams only. Your design needs to accommodate for accessibility standards. And yeah, lastly, we suggest to introduce some automated checks to make sure that your progress is not undone. It would be a pity if you invest on accessibility only to find out that a follow-up PR made it inaccessible again. Some tools you can use for this are just Axe. We're using this one, and it helps you write unit tests that check for correctness in the DOM structure itself of the components you render with Jest. Another tool you can also use, we haven't experienced it yet, but I know it's very popular, is Lighthouse CI, which you can hook very easily to pull requests and provide different levels of reporting of the changes that are happening there. And yeah, that was most of it. So yeah, we're working on making our board experience accessible for every human. So we are working in making Infinity accessible for all. And if this is something that intrigues you, come join us for sure. Lynn, back to you.
Yeah, awesome. Thank you, Gonzalo. We have a question here from Lido. How do you test accessibility in your code? For example, screen readers.
That's a good question. I think for now, we don't have tests that go on the end-to-end experience. Like we don't have automated screen readers that just try to interact with our app. What we do is a lot of manual testing at the moment, and we are introducing this automated test with Jest Axe. And Jest Axe does a couple of checks for you. It's not perfect. It still cannot find, or it cannot know more than you tell it via your own code. For example, I don't know, if you have for example, a radio button group, and in the final page, it is rendered below a title. If you test only your radio button, it cannot know that the title is correctly connected to it. Maybe if you pass some reference IDs, but I don't really think we have the solution for this yet. We're just checking DOM structure and yeah, assessing that the correct attributes are there through automation in unit tests mostly.
All right. And yeah, we have a couple of other questions as well. One from Aryan. I'm not blind, so forgive my possibly ignorant question, but even with proper A11Y, I don't know how to say it, can a blind person effectively use Miro? It's so free form, or are you just using A11Y for automation and such?
That's a very good question. I don't know about blind people in particular. I'm sure there are some examples of people that are trying to use it. The board experience currently, I don't think they will have a very good experience in trying to maybe collaborate like me or you maybe could. But I don't think there should be any like theoretical roadblock to avoid it. I think interfacing with correct screen reader technologies should definitely be possible. But again, as I mentioned before, in order to achieve this, we are working on a major redesign of the board experience itself. It's not that we can just add a couple of attributes to what we currently have, and it will be accessible for all. Maybe the patterns of how we interact with the tools and how you can access it via keyboard need to change in the accessible version of the board experience. I hope that answers the question.
Oh, all right. We have another question that came in from Ahmed. Can't the robots just use an API?
Yes, if you have a public API. If you don't have a public API, maybe not. And the thing I find with APIs is that There's also no standards for API. Some can use an authentication token, some can be just public, some can require, I don't know, login and password to send in every request. But with websites, we already have a working solution which you can do everything with. You don't need to build a separate API for robots maybe to interact with. But for sure, I think the robots we know of right now are interfacing with APIs. You could consider Amazon Alexa is some kind of robot, Siri is some kind of robot, and yeah, they interface with APIs. But if I wanted to go to booking.com and I don't know, book a hotel, I don't know if there's a public API to do the whole flow, for example, or with Miro. I think Ahmed could talk more about the SDK, but currently you cannot do, I think, everything in Miro just through an SDK, right? An API.
No, we do have a public API and we do have like the SDK, but yeah, of course, it doesn't have all the functionality, no.
All right, thank you. We still have a couple of more minutes. And just another question for Gonzalo. What component was the hardest to make accessible?
Nice question. I think the components that were, or at least in my experience, the hardest one were all that involved a dialogue or some sort of pop-up overlaying the original content, mainly because in those situations, you need to decide what to do with the focus. The focus needs to kind of be trapped in the new component. And then when you leave this kind of interface, be it a dialogue or a pop-up, the context needs to go back to the original component, or you need to try to do it. In some places, we were able to achieve it pretty easily. In some others, we needed some black magic in order to restore focus where it was supposed to be. But yeah, there are also some tools available, especially for focus trap. It's a very common problem. But yeah, when we started with it, we didn't have almost anything. So it was all discovery period first.
And did you have to change some flows in order to make them accessible?
Yes, we did have to change some flows, or not the whole flows, but some parts of the flows. For example, we have a problem right now in which tooltips cannot be made interactive. So our new versions of tooltips do not support links, for example, because of all of this thing with the focus trapping. So in some places, we just decided, okay, we'll just go for plain text in tooltips and put the link in another place. And yeah, that involved a design change because they originally were hidden from all users, and suddenly the links are visible to all, so not just on hover. And yeah, that has design implications. There's just one more blue thing there in all the designs, or at least the ones we were changing.
Right. All right. Yeah, I think we're almost at time. And so thank you for all your inputs, all the learnings. I'm going to announce the winners for the questions. So we have 2 questions with the most votes. One is from Ahmed and the other one is from Stuart, both with 3 votes. And yeah, since Arjan, you asked a lot of questions, we'll count you in as well. Yeah, so if you could please send me your home address to lynn@Miro, that will be very good because then I can send you something. But yeah, thank you everyone for joining today. And I hope you all learned something that you can take with you. And before I let you go, I also created a very quick feedback survey, which I'm going to share with you in the chat. So please, it only takes like 1 minute, and we would really appreciate it. And yeah, thanks again and have a great evening and hope to see you again next time.